A data model provides an on-the-ground view of the data. Much as a building is not built without a blueprint, a database should not be built without a data model. Data modeling is labor-intensive and time-consuming. It is generally performed by the application developer or the vendor and used by anyone who must customize screens and templates in the application. However, end users should appreciate the need for a data model to ensure that all data required by the database are represented completely and accurately. There are three outputs of data modeling. For most databases used in an EHR or other types of application processing unique patient data, a use case may be developed to illustrate the activities of a particular system being modeled. This is suitable for and should be shared with end users. Although a use case may use special diagrammatic tools and rules for construction, such as supplied by the Unified Modeling Language, UML, a use case can be constructed in a simple table where one column identifies how data are entered and used by the user, and another column describes what the computer does to process the data, such as user enters drug order, system alerts user to patient allergy. A second output of data modeling may be an entity relationship diagram, which is constructed as an easy-to-read picture of the logical relationships between data to be collected, its properties, and relationships. For example, it can identify that an order requires the patient name, drug name, dose, etc. And it can allow one physician to write one order or many orders, but each order can have only one author, but there can be multiple counter signatures. The entity relationship diagram, in other words, help establish the rules around processing the data. A third output of data modeling is the data dictionary, often compiled into a database that provides data about the data, which we refer to as metadata. There may be three types of metadata described for every data element described in the data dictionary. Descriptive metadata provides definitional information, and we'll look at this in a moment. Structural metadata describe how data are captured, processed, stored, and displayed. Administrative metadata is information collected as the data are actually used, including audit logs of who accessed what, decision support, and other rules actions. Did the user adhere to the alert, ignore the alert, modify the alert? And data provenance, or where data originated and the journey the data may have taken as it is processed with other data and shared with other applications. As we mentioned, a data dictionary is used to keep track of all the data elements in an application. EHR vendors maintain a standard data dictionary representing all the data in their standard applications. As users begin to use the applications and want to add or delete data elements, the data dictionary should be used to manage the changes, either at the vendor end or the user end, depending upon the authority the vendor gives the client. Many vendors prefer not to allow users to make changes, often because there are so many relationships between data elements that a user may make a change to one data element and fail to make applicable changes or even check all of the relationships impacted. This could severely impact the integrity of the entire system. Some vendors, however, do support certain changes to the data dictionary, especially if they supply a toolkit that enables users to do so correctly. And I do want to note that in this case, user is specifically trained IT staff at the client site. Hopefully no one would ever give such authority to an end user, such as a physician, nurse, or even informatics staff member. In fact, I believe any change should be made or requested of a vendor only when all stakeholders are at the table and fully understand the impact of a change. And we'll look at this in a minute. Change control, also called configuration management, is a term used to describe the management of changes. The description of changes should be retained for the statute of limitations in your state at a minimum. As you can suspect, even collecting all the identified data for one data element and any subsequent changes made to any of the data, even such as changing from ICD-9 to ICD-10, is a monumental task and requires a huge database. The attributes that are maintained about data in the data dictionary are generally descriptive metadata, although many EHR vendors incorporate some structural metadata and tools or linkages required to describe some of the administrative data. The International Standards Organization, International Electrotechnical Commission, IEC, 11179 Guidelines for Metadata Registry or Data Dictionary Construction promote uniformity of approach in data dictionary development that contributes to semantic interoperability, that is, data comparability. Not all vendors use this standard, but most adhere somewhat closely to it. In the example I've provided on this slide, I've got some definitions of terms related to the elements that we usually see in a data dictionary. For example, there will be an entry name, which is the name of the data entry field. It might be patient name, for example. Table is the location of data in a relational database where there are many tables relating to one another. This would be identified in your data modeling and information modeling. Physical name is a unique identifier in a database. Synonyms may be other names that may mean the same thing. In general, we want to avoid synonyms, but it isn't always possible. Definition refers to the standard definition of the particular data that is identified by the entry name and physical name, or the usage in the EHR specifically. Reference refers to the authority that has provided the definition. Is it the Merriam-Webster Dictionary, or is it a Stedman's Dictionary, etc.? Derivations. Data derived from processing other data. So does this data come from some other source? Age, for example, can be calculated by comparing today's date against a birth date. Valid values specifies the nature of data to be entered and flags for incorrect entries. In other words, we should not be able to enter 1000 degree Fahrenheit for a patient's temperature. It's not a valid value. Conditionality refers to whether an entry is required or optional. Default means an entry pre-populates and may be changed by the user. For example, we could have the today's date default, and the user would have to change it if it wants to refer to a different date. Lexicon refers to the vocabulary used to identify terms. So in this case, we might have ICD-9-CM or SNOMED as a lexicon. We'll talk more about this in the unit on interoperability. Relationship. What action is triggered by this entry? Access restrictions certainly identify the security access controls, and process rules might be described here as well. And these would be internal references for processing, such as a clinical decision support rule, the generation of a report from this data, or causing the next display to present to the user. As I noted, end users may and should become involved in reviewing data models in the data dictionary with its metadata when changes need to be made to the system, especially relating to data used in clinical decision support systems. Even if the organization does not have the capability themselves to make changes, end users need to understand the complexity of any request for change if only to appreciate why such a request to a vendor results in a high fee charged for the change, or a response that indicates they can't or won't make the change. And I have an example here on this slide. Let's say there are 5 data elements we'll call data element A, data element B, C, D, and E. And they are required for every drug order to be entered, and the system will not permit advancing from one screen to the next or exiting the system if all 5 data elements, A, B, C, D, and E, are not addressed. However, if it were decided to not include one of the data elements, let's say not E, there could be implications for not receiving an alert when a given patient has recorded data relative to the data element that is E. For example, E may represent how a drug should be formulated. Because such formulations are relatively standard, many physicians feel like it's a waste of time to enter this data every time they use the computerized provider order entry system, even if it's only one more click. But perhaps in the group, it is determined, the group that's assessing whether this should be changed, perhaps it's determined that in 99.9% of the orders, the formulation is in fact standard. However, if not being able to tolerate the standard formulation could cause death in the vast majority of cases where such is needed, a very small percentage, but perhaps 98% of the time, there is a death that results from the formulation not being changed. This factor must be considered in deciding whether or not to drop the data element E formulation. A review of the data model and how the rule is processed can help determine the potential for risk if the alert is not provided. The example here is also a good illustration of why many clinicians believe that structured data entry takes longer because they are required to enter more data. This may be true, although generally the improved level of precision reduces downstream time wasters, such as the ordering physician having to be called by the pharmacist to find out whether this drug should be done in the standard formulation or not. One solution is actually an even more sophisticated system where what data are to be collected can be driven by context, and some data elements can be optional and or default to certain values. For example, a computerized provider order entry system could default to the standard formulation unless a physician invokes the special formulation function. Will the physician remember to do so? The pros and cons of such a default structure need to be understood with respect to the level of risk it imposes in any change made to a system. In summary then, data quality refers to the characteristics needed to ensure that the processes by which data elements are accumulated yield complete and accurate data. Decision support is applicable to the patient's clinical situation. Analyses performed result in useful information, and outcomes of any data use can contribute to providing the highest quality care and patient safety. Essentially, the quality of the data must support the EHR 5 rights of having the right clinical data, achieved through the right presentation, perhaps in templates to capture data and displays that provide information, in support of right decision making provided within the context of the right work processes in order to produce the right results. The data quality principles of accuracy, accessibility, comprehensiveness, consistency, currency, definition, granularity, precision, relevancy, and timeliness were introduced to healthcare by the American Health Information Management Association in its Data Quality Management Model Practice Brief in 1998 and has been continuously updated through 2015. Many corporations have applied these same principles to improve the quality of data upon which business decisions are made. Intelligent Solutions Incorporated, for example, notes that the viability of business decisions is contingent on good data, and good data is contingent on an effective approach to data quality management. It recommends starting an education campaign and instilling good stewardship into an organization as a means to emphasize the importance of data quality management. As EHRs and many other forms of health IT are challenged to ensure the quality and safety of healthcare today, avoiding unintended consequences depends upon quality data processed efficiently and effectively. The old saying, garbage in, garbage out, is probably more true today than ever before.